Right, this is the final section of the C4 booklet. Section 24, problems involving lines in 3 dimensions. So this comes basically a section dealing with a lot of questions that are basically targeted at A-star students. So do take that in mind. Now, as usual, this is a video and not a normal lesson, so you may need to pause in order to take notes. So, in the C4 notes booklet, we're on page 61. Example 1. The point P lies on the line R such that the line OP is perpendicular to R, and we're to find the coordinates of the point P. So the point P is a point on that line. So there must be a value of lambda so that it corresponds to the point P. So we would say that OP equals 3 plus 2 lambda, so I'm looking at the x coordinates alone here, so 3 plus 2 times lambda, y coordinates 14 minus lambda, and for the z coordinates minus 2 plus 3 lambda. So that would be a coordinate for P or a vector for OP. Now we need the vector OP to be perpendicular to R. So that means that the vector OP is perpendicular to the direction vector V1. So what we're basically saying is, and this is a bit of a mix of notation, the scalar product of OP dot with B1 is equal to 0. Because they are perpendicular. So 3 plus 2 lambda, 14 minus lambda, minus 2 plus 3 lambda, dot product with the direction vector of the line, 2 minus 1, 3, equals 0. Apply the dot product formula, 2 times 3 plus 2 lambda, minus 1 times 14 minus lambda, don't really need to write 1, plus 3 times minus 2 plus 3 lambda equals 0. Multiply out all the brackets, 6 plus 4 lambda minus 14 plus lambda minus 6 plus 9 lambda equals 0. Collect like terms, 14 lambda minus 14 equals 0. 14 lambda equals 14, lambda equals 1, divide both sides by the 14. So we have the value of lambda. From the coordinates of the point P, we stick the lambda in to get the vector OP. So we put the lambda into OP and calculate. But we technically want coordinates rather than a vector, so we would write them in coordinate form. Though generally if you give answers to this in position vector form, they will still give you the full marks. So first line, 3 plus 2 times 1 is 5, 14 minus 1 is 13, minus 2 plus 3 times 1 is 1. And the coordinates of the point P is 5, 13, 1. So this is one of the more common extension questions for vectors. Less common, but still fairly interesting. The point A is position vector A equals 2i plus 2j plus k. Point B is position vector I plus j minus 4k relative to the origin O. Find position vector of the point C with position vector C given by C equals A plus B. So that's fairly straightforward. Stick in the values. 2i plus 2j plus k plus I plus j minus 4k collect like terms. 2i plus I is 3i, 2j plus j is 3j, k minus 4k is minus 3k, and that's the vector C. Now the next part, we're to show that OACB is a rectangle and show its exact area. Well, when we draw a sketch, we'll draw it as if it is already. So we've got O, A, C, B. So O to A is the vector A. O to B is the vector B, but by the virtue of what we created C, A to C is a vector B, and B to C is a vector of A. So at this point, we've got two possibilities. It's either a parallelogram or a rectangle. Now it'll be a rectangle if one of the angles is a right angle. Because for a parallelogram, the opposite angles will be equivalent. And they all have to add up to 360. So if one's at 90, that one's 90. These two have to be the same, so they'll have to be 90 as well. So we only have to find that one pair is 90 degrees, perpendicular to each other, the whole thing's a rectangle. So basically, vector A and B, if we do the scalar product, if it's equal to 0, then they're perpendicular and the whole thing's a rectangle. So 2, 2, 1, dot with 1, 1 minus 4. So we get 2 plus 2 minus 4, which equals 0. So therefore, A and B perpendicular. Therefore, OACB is a rectangle. So an interesting one, only turned up once in an exam. Well, I thought it was sufficiently different to be worth adding to this section. Final example is a bit more common. In that you work out some of the things using the more simpler techniques, and then once we've got that, a sketch and the information we've worked out and the information we're given allows us to find something new out. So in this case, find the value of cos theta. So we've got two equations of the line. We know the intersect at the point A, which is minus 6, 4, minus 1. Point X lies on L1 where lambda equals 4, and the acute angle between L1 and L2 is theta. Now we want to find the value of cos theta, so basically scalar product technique between the two direction vectors. So we'll call that one B1, that one B2. So start part A. B1 dot B2, multiply the x's, 4 times 3, multiply the y's, minus 1 times minus 4, multiply the z, 3 times 1, and calculate. So 12, 16, 19. Note that we're asked for cos theta here and not the actual angle theta. Magnitude B1, square root of 4 squared plus 1 squared plus 3 squared. Which is the square root of 26. Modulus of B2 is 3 squared plus 4 squared plus 1 squared. So if we calculate calculate is also root 26, same calculation, different order for the numbers. Stick them into the scalar product formula. So 19 equals root 26 times root 26 cos theta. So cos theta divided by the square roots. And then simplify. You could use a calculator to simplify, but in this case, root 26 times root 26 is 26, so it's 19 over 26. Then we're asked to show that the modulus of AX equals 4 times root 26. So we've got the point A, which is minus 6, 4, minus 1. We need to find the value of the coordinates of X. X is on L1 where lambda equals 4. So for X, doing it as a coordinate rather than a vector. So this is L1, minus 6 plus 4 times 4, comma, middle coordinate, 4 plus minus 1 times 4, plus, minus, sorry, not plus, final coordinate, minus 1 plus 3 times 4. So calculating 10, 0, and 11. We want the vector going from A to X. So A was minus 6, 4, minus 1. So the vector taking goes, well actually let's do it the other way, taking goes from A to X, minus 6 to 10 is 16, 4 to 0 is minus 4, and minus 1 to 11 is 12. Therefore, using Pythagoras, the magnitude of A to X equals square root of 16 squared plus 4 squared plus 12 squared. Plug it into the calculator. And we get 4 root 26 like we're supposed to. The point y lies on L2. Given that the vector yx is perpendicular to L1, find the length of AY, giving your answer to 3 significant figures. So we've got 2 lines. So sketch is usually very helpful for these sort of random questions. So we've got L1 and L2. We've got the angle between them is theta, where cos theta equals 19 over 26 from part A. We've got the point X, which is on L1. So A is where they cross. X is on L1. And we're told that A to X is 4 times root 26. We want the point Y on L2 so that YX is perpendicular to L. 1. So we want that to be a right angle and that to be Y. And we want the distance A to Y. Now basically, once we've got the sketch and put the information we've already know on it, it becomes a trigonometry question. So we want A to Y, which is the hypotenuse. So cos theta equals the adjacent, which is A to X, over the hypotenuse, which is A to Y. So switch those two around. A to Y equals A to X over cos theta. So A to X is 4 root 26. Divided by the 19 over 26. We'll get our calculator and we'll get our answer. And to 3 significant figures, 27.9. And that's it. So, as I say, this is very, very common. So the earlier parts are standard questions. The last part, a sketch with all the information given, plus all the information you've worked out, and it very often results in some sort of trig or some other easy GCSE level sort of calculation. But without the sketch, it's impossible to tell that it is as simple as that.